Hello all. So let's begin with the problem of search in a rotated sorted array. So here's the problem statement that we are given an array nums and they are sorted in ascending orders. Okay, all the numbers are sorted, but provided it's a distinct value. So we will solve two problems. Okay. So first is search in a rotated sorted array where we have all the distinct values. And there is second problem which is similar to this problem. Okay. So in the similar questions, we will find it that here we'll solve this as well where they are not necessarily distinct. Okay, so these are the two problems, both similar, just one thing needs to be taken care of. So we'll see that, but firstly see what is this rotated means. Sorted array, we know what does it mean by rotated, so they have explained it here, but I'll take the blackboard to explain. So let's say we are given this array. This is not right now, it's not rotated. Okay, but this is just a sorted array. You can see it's all distinct values and they're all sorted. Now what if I say rotated sorted? So it means what you have to do, you have to just take this 7 here, okay, and push everything. So it's like if I write, it will be like 7 0 1 2 3 4 5 and 6. Okay, so this is like we have just rotated it once. Okay, now let's rotate again. Then what we will get? 6 7, and then again we will start from 0 1 2 3 4 5. Then again we will do, then it will be 5 6 7, and then 0 1 2 3 4. Correct. So this is what they have explained, that for example this is the sorted array. Then if we rotate it, so whatever is index that we use to rotate, it's called usually pivot index. Okay, so index 3 means which one will be the index 3? Index 0 1 2 and 3. Sorry, I have to count here. Index 0 1 2 and 3. So if I rotate this array at pivot index 3, it means that it's so simple. Just start writing the array from that index value. So just start writing from 4, and when you are done, just start writing the rest of the elements as it is, which was this one. So this is like, this is what we did in the blackboard, or just we have to do once more. So if I'll do just one more iteration, then it will be 4 5 6 7, and then 0 1 2 3. So this is how we have rotated now at the pivot index 4, or sorry, index 3. This is index 3, but the value is 4. So we can say this is a pivot index. This is simple definition that whatever index is given, just write it, write all the elements as it is, and then write rest of the elements in the same order. So this is what the definition is. So the task is, we are given the target as well, and we have to find that target in this, and if it's there, then we have to return its index value, right? So return the index of the target if it is present in nums, and if it's not, then just return -1. That's what is given. So obviously we will use binary search. We know a binary search, it's so simple, so we will do that. But given that it's a rotated sorted array, now we know that binary search only works when we have the entire array sorted. But here if you will see just this array, forget about rotating on anything. If we are given just this array, we can't apply binary search here. Why? Because for binary search, first and foremost condition is we need arrays of our numbers in ascending order, and it's not this case here. What we can do? So there is something that we need to observe in rotated sorted array. That one thing I'll write is that in a rotated sorted array, most important thing, that at least one half, please note at least, so both can be sorted as well, but at least one half is always sorted, and we will utilize this functionality or this observation of the rotated sorted array. Okay, only this occurs only in rotated sorted array cases. Okay, because we know that since we have rotated with the pivot, you can say that if I consider this left half is like, for example, this is the mid value, right? Then you can see this is sorted 4 5 6 7. But if I'll see the right half, you can see we have to consider from the mid. Okay, If I just consider 0, 1, 2, then it's sorted, but we have to consider from the mid itself. So you can see this is not sorted. You can see 7, then it's going 0, then 1, 2, 3. Then so this is not ascending sort. But 4, 5, 6, 7 perfectly sorted. Okay. So we'll utilize this property that at least one half is sorted. So what we will do, firstly we will check whether left half is sorted or not. Okay. So that's the first step. So obviously in our binary search, first step is to find mid. So let's write that step by step, that if my nums of mid, firstly we'll calculate the mid, which is low plus high minus low by 2. And we know that why we do this, to avoid integer overflow, or else you can just, in Python it's fine if you write low plus high by 2, it doesn't matter because Python will internally do it. Okay, but in C++ and Java you have to specify like this. Why? Because let me just take a moment to explain that in this case what will happen. For example, let's say if we use this thing, and let's say both our low and high values are so high, and we know that the range of integer is from 2 power 32 minus 1 from minus 2 power 32 or 31, I guess. So this is the lower range and this is the upper range. So our integer range is this much, and let's say our low and high are so high that they are around 2 power 32, and if we add both, okay, then this range will be exceeded, and we will move to, and we know that what happens, that this is the left range minus 2 power 31 and this is 2 power 32 minus 1. When we exceed this, then we come to negative side. So instead of the correct calculation, if we use this in C and C++ or Java, then what will happen is there will be something called as integer overflow. Okay, and that's why what we do, firstly we subtract those two big numbers. If the numbers are too big, the subtraction will be really small number, right? And then we can add this, and this won't, okay, allow us to have the integer overflow. So that was the reason to use this. So let me write again that mid equals to low plus high minus low by 2. First we will calculate mid. Now we will find, obviously first thing is, if my mids is same as target, then we are done. We can just simply return the mid value because we have to return the index. Okay, firstly of course low will be 0 will, and high will be length of nums minus 1, which is n minus 1. Let's say n is length of n. Okay, so we know our binary search things. I just repeated this integer overflow. Okay, so firstly what I have to check, we have to check whether, if this is not the case, when if we find it mid, we will just simply return. But if this is not the case, then we will check whether it is left sorted, or we will check it is right side is sorted or not. Okay, right side is, so it's not like left, this is written like left side is sorted or not, this is written right side is sorted on. Okay, so this is what is written. Now what we will do is simply calculate the condition to find whether left half is sorted or not. So how we will do that? We know that this is simple. You can observe from here that if my, firstly my mid will be this, low is here and high is here. What we will check is if my nums of low, which is this number, is less than or even equals to, right? But why even equals to? We will see that. If you don't get it as of now, we will see that in one of the case, that if my nums of low is less than or equals to nums of mid, okay, then we will say that my left side is sorted. Correct? Equal to might not be clear at this point, but we will see that. Okay, I'll tell you one case when this will happen. So what's the condition? If my nums of mid is less than or equals to my nums of, sorry, nums of low, here it should be low, let me erase it and write. So if my low is less than or equals to mid, then we can say my left side is sorted. Okay, Now if my left side is sorted, okay, then we will check whether my target, which is 0, lies here in this range or not. Okay, firstly you have to check left side is sorted, so this is the if condition, and if it's not, then we will directly move to this else part, but we will focus on this else part later. But if this is sorted, then again inside we have to check one more if, and this if is for to check whether my target lies in this range or not. So it should be like something like this, that whether my nums of low is less than or equals to target, and my target is less than nums of mid. You will notice that I haven't written equal to here because that condition will be taken care here, that if my mid and mid value is equals to target value, then we will directly return, right? That's why here equal to is not needed. Okay, that's why I just ignored equal to here, but here it will be needed. Here should be less than or equals to target. Okay, if this is the case, it means that my target is lying between this range. Okay, but in this case it's not. Okay, or if we consider target as 0, but what if it's lying, then what we have to do, we have to discard the right side. So what we have to do, we have to shift our high to mid -1. Okay, so we will do that. In this case, what we will do is, let me change the color in right, that if my, then we will put high to mid -1. But if this is not the case, then what we will do, let me just shift this somewhere. That if this is not the case, then I'm writing the else part of inside if. Okay, then obviously the other way around, that if this is not the case, then we will move low to mid +1, which means if my target, which is in this case target is 0, and this is the else condition, that if my target doesn't lies in the left half, then of course it lies in right half, so we will discard all this. So we'll move our low from 0 to, which was here, now we will move to mid +1, which will be here now. Okay, so my entire this array will be discarded, 4 5 6 7, and now my low is here and my high is here, and we will continue. Okay, so we have discarded, so easily we are using binary search somehow. Okay, now let's focus on the right side, that if my left half is not sorted. Okay, if this is not the case, then what we will do, for example, that here our left half is sorted, but let's say in some case where my left side is not sorted, let's consider such case. Okay, so when will that happen? So for example, if I have array something like this, that 8 0 1 2 3 4 5 6 7, then you can see our mid will be how many elements? Mid will be here, right? 4 elements on the left, 4 on, yeah, odd. Okay, so yeah, mid will be this, and you can see our left half is not sorted now, even though this is rotated. It is rotated just once around this index, I mean along 0, where the value is 0. Okay, along that index, if you will just rotate, so it just rotated once. Okay, so we can say that. So simply, if this is some like this, then obviously left half is not sorted. Then where we will go? We will go on the right side. Okay, so we will go on the right side, and on the right side we will tend to go to the right side. What we will do? Okay, then simply we have to write that we know that our right side will be sorted, but again now we are at this condition, we have to check what is our target here. Let's say we are searching something which is in this range. We will check also, we'll change the target again, but let's say we are searching 6, then we know that which is in this range, but firstly we have to check the condition as well. So this else will be executed only when we will check that this is not satisfied. That is, it is not left sorted. So it means we know that at least one half is sorted. So this is sorted, and you can see this is sorted 3, 4, 5, 6, 7. It is sorted. Okay. So we will come on the, so this else, inside this else again we will need one more if to check again the range. Okay. So now here we have to check whether my target lies between what? Between nums of mid is less than target and is less than or equals to nums of high. Here again you can see here I have to include, but here no, with mid and target, because if this is the case then this will take care of it. Okay. So again this will check whether my target lies in this range or not. Okay. So if it lies, then what we have to do, we have to discard the all these elements. Okay. So what we have to do, we have to just simply say load test mid plus 1. Okay, just shift my low here, and high is already here. Now this is my new array in which I have to search. Okay. So if I finished for this 6, okay, let's not finish. Let's say now target doesn't lies in this. Let's say I'm searching for 0. As I said, I will, because I have to write the else part of this inside if. What if my target doesn't lies in this range? For example, let's say we are searching for 0, and we know that even though left half firstly left half was not sorted, so this else will be executed. But we know that now inside this else we are going to check whether my target lies in this range, and target doesn't lie. What we have to do, we have to again go to left side, and how we will go there by just saying I equals to mid minus 1. So in that case, what we will do, we will just shift this I from here to mid minus 1, which is here. So now I will start checking from within just this range from 8 to 3. So you can see this two. Okay, let me take this. So you can see this two are, this condition is here, this condition is here. You can see they are like kind of mirror image, that here it's in if, but here it's in else. Okay, and vice versa. So it's that simple, that we are just shifting our focus, and then we will continue this until my low is less than or equals to high in the while loop, until my low and high doesn't cross each other. So if you want to dry run this thing in one of the examples, then let's do some dry run. So it's more clear that what I mean. So sorry, I used highlighter accidentally. Let's use pointer. Okay. So what will happen now? Let's put this here, and we have to do this in a while loop. Okay, until low and high doesn't cross each other. So let's use the same example. So that it's more clear that 8, 0, 1, 2, 3, 4, 5, 6, 7. And what we have to do, firstly low is here, high is here, and mid is this one, right? Yes, and this is the mid. So we will check first, after calculating the mid, if it is equals to target. Let's say we will take both the cases. Firstly we are searching for let's say 6. Okay, easy case. So firstly we will check whether left half is sorted or not. No, it's not. So simply we will directly jump to this condition else, that right half is sorted, and you can see this is sorted. So what we have to do, right half is sorted, we have to check whether my target lies in this range or not. Yes, it lies. Then simply we have to shift this 0 from here to mid plus 1. Now we have discarded this entire range. Okay, and now we are, our new search range is just from this to this, low to high. Again, our while loop. Again we will calculate mid. Now the new mid will be, until low and high doesn't cross each other, we will continue this. So new mid will be this 5. Okay, where 5 is. So now again we will check whether left side is sorted or not, and you can see this time left side is sorted, 4 and 5, this is sorted, correct? So we will go inside this condition. Now we will check whether my 6 lies in this range or not, 4 and 5. No, it doesn't. So what we will do, we will consider this else part in the bottom, and else part says go to move your low to mid plus 1. So let me erase nicely. So this low will be erased. Let's erase the previous as well, and our low will go to, even this was the old mid, now my low will be here to mid plus 1. Okay, because previous mid was here at 5. Now our new range is this. Again, we will calculate the mid. We know that mid will be at the same position where low is. This will be our new mid. And now we already know that this is equal to target. So we'll directly return mid. Whatever is the index at 6, we will return directly. That's it. We are done. Okay, but let's now change the target. As I said, let's say my target is 0. Then what we will do? Let's redo everything. So again, 8, 0, 1, 2, 3, 4, 5, 6, 7. Firstly, low is here, high is here, mid is here. We'll check whether target is equals to mid. No. We'll check left half is sorted. No, we know that in this area it's not sorted. So we'll go to the right half. So here. Now we will check whether my 0 lies in this range or not. So in this else condition, we will check this. No, this is not satisfied. So we will go to this else condition. It says that move your high to mid minus 1. So we will take this high to here, mid minus 1. This is my new high. Okay, now this new mid will be between this low and high, which will be this. This will be my new mid. Again, we will check if my mid is equal to target. And yes, we are perfect. So it's done. So this is how it works. So let's quickly write down the code for this. Super easy. Okay, so I'll write it in the same way, that firstly low and high we have to initialize. Low is 0 and high is length of nums minus 1. Now what I have to do, firstly I have to find mid. Okay, I haven't written while loop. I'll just, for the explanation purpose, nicely. Okay, either I can write start plus low or low plus high by 2, or start. Sometimes I write start instead of low, so that's why you can write like this. But if you are a good programmer, you won't like write like this, and rather you will write like low plus high minus low divided by 2. Okay, I'm just commenting this for your reference. Okay, we are finding the mid. What we will do now, firstly we will check whether left half is sorted or not. Left half is sorted or not. For that, what we will check, we will simply check. Okay, first things first, not left half. Firstly, what if we find our targeted mid? I don't know why I forget this condition. So if my nums of mid is equals to target, then I'll simply return mid. Don't have to do anything. If not, then I will check for rest of the stuff. Okay. Now you have to check which left half is sorted or not. So how we will check if left half is sorted or not? So we can write like, if my nums of low is less than or equals to nums of mid. Okay, I still have to explain why I taken equal to here. Okay, so what if I just have one element in the array? What you will do? Then in that case, low and mid should be same, because low, mid and high all will be at the same position, right? So, and we can say that low left side is sorted. Okay, or we have two elements, then low and mid are at the same position. Let's say not consider one element, let's say two elements in the array, then low and mid are the same position, right? Then still left half is sorted because just one element is sorted in itself, right? And that's why equal to is needed. Okay. So if this is the case, then we will check if my nums of mid or I can say my nums of low is less than or equals to target, and here not equals to, just less than, and is less than or equals to mid. That is, now I'm checking if my target lies in the left half or not. If it lies, then we don't need to check in the right half. So just bring the right, that is high, to mid minus 1. But if this is not the case, then we have to go to the other side. So, and outside this now, that if my this is for, so it means right side is sorted. In this case, what we will do, again we will check if my target lies in this range or not. Means if my nums of mid is less than target and is less than or equals to nums of high. That is, if my target lies in the right half from mid to high. Then if it lies, then we have to move our low pointer to right side. That is, bring low from left side to right side, so mid plus 1. But if this is not the case, then the other way around, that is high equals to mid minus 1. As I said, here high equals to mid minus 1 is in if, here it will be in the else, mirror image. And if there isn't an element, then we will simply return minus 1. But this thing, this entire thing, we have to continue, right? Sorry. So we will write this entire thing in a while loop. Every time you have to continue this process until my low and high don't cross each other. Okay. As soon as they cross, we are done. And if after everything is done, still we didn't hit this condition of nums of mid equals to target, it means that we have to return minus 1. We are out of the while loop and we have to return minus 1. Let's try to run this. Accepted. Working fine. Now let's quickly go here. Now what will happen in this case? Here it's the same code. If you will see, nothing has been changed. Okay. Here just the change is, rather than giving the index, we have to just return if it's present true, and if it's not, then false. So rather than returning here the index or the mid value which we did here, okay, just we have to return true. And if we don't find, then at the end outside, instead of minus 1, we are returning false. Okay. So again, I have written that in rotated sorted array, one half is always sorted. Okay. So all this code is the same. Okay. This code is totally the same. But here, the only thing that is that this is the hard problem, or sometimes it's medium problem, you can say. It's not necessarily with distinct values. So you can see we have repeating values. And because of this repeating values, it's a bit hard to check the left sorted and right sorted. It's hard in this case. For example, this is the array. Then what will happen? My low, mid and high, all of these are at the same value. And they see, then in this case, what you have to do? We have to just simply ignore this. That because we know that we have to just find whether this element exists or not. If it will exist, it will be caught here only. Okay. Here for target is 0. Okay. This is for, let me also write target 0. For this case, okay. So if you will not write this condition, let's not write and submit, then what will happen? See, it's failing, and that's why I particularly copied that condition. That what's happening is that here you can see this, and this, all three are of the same value, right? Then how we will check whether it's sorted or not? Because for sorted, we need to, if left half is sorted or right half is sorted, at least one half is sorted. If we want to check that, We can't check that, right? Because for checking what we are using, we are just comparing my nums of low with nums of mid. But in this case, all of these values are equal. And this is a bit strange, right? So what we will do is, if that happens, we will just simply move by one position our low. So my low will be here now. And we will simply put my high. So we are bringing both of them close to each other. Okay, sorry. So what we will do, high will be now just here. Okay, and now this will be our array, just this much. And now we know that here the mid will be this middle one, and left half is sorted now. So we can now continue the same process. The left half is sorted, and we will check whether 0 lies in that left half range. Yes, it lies. So we'll bring our high to mid minus 1. Okay, so high will be brought to mid minus 1. And we know that now new mid will be here and it will be caught directly. Okay, that's why this condition is needed. And that's it. Okay. So sometimes it also happens that, let's say, in our mid was different. Okay, let's say instead of this one, we had something else. Okay, and here we had 2 and 2. Let's try to run this if this works or not. See, it won't work for this case. If I So you can see here that this and target is 1. Okay, so if we write this only nums of low I equals to nums of high, then this is not correct, because then we are just moving our low here and our high also here, and we are ignoring just one, and we have to find one, so we are just ignoring our one. This is not good, and that's why we have to write all these three conditions, okay, together. So that's it about the video. I guess it's a bit longer, so stay tuned, keep learning. Ciao.